Hi students, welcome to our class. Today we are going to discuss about factors affecting resistance of a conductor. Consider this as the conductor. The length of this conductor and its area of cross section that depends upon the resistance of the conductor. Then how this length and area of cross section depends? For this we can write resistance which is directly proportional to length of the conductor. That is, when length increases, resistance also increases. Again we can write resistance is inversely proportional to area of cross section. Due to that inverse relation, we can write R is directly proportional to 1 by A. When area increases, resistance of the conductor decreases. Okay, on combining these two statements, we can write R is directly proportional to L divided by A. Then resistance R equal to a constant. On removing this proportionality, we can write a constant rho into L divided by A. This letter pronounces as rho. Okay, this letter pronounces as rho. Okay, rho is known as the resistivity of the material. Or it is again known by the name specific resistance. Okay, rho is known as resistivity or specific resistance. And this resistivity which depends upon the nature of the material. Okay, resistivity that depends upon the nature of the material. We know that every metal have different nature. So, the resistivity of every metals are different. We can say that the resistivity of copper is different from that of aluminium. Resistivity of aluminium is different from that of silver. Like that. Okay. Then, what are the factors that depends upon the nature? When our nature changes, a normal condition, our nature is also normal. But what will happen when the temperature increases? That is, when we are tempered, what will happen there? Our character totally changes. Okay, just similar to that of our character, metal have its own character and that character also changes with the temperature. Okay, or resistivity of the material that changes with the temperature or the nature of the metal that changes with the temperature. From this, we can say that what are the factors that affecting the resistance of a conductor? First one, resistance is directly proportional to length. Second one, resistance is inversely proportional to area. Third one, it again depends upon the nature of the material. Okay. Again, nature of the material changes with the temperature. So, we can say that there are four factors that affecting the resistance of the conductor. First one is length, second one is area, third one is nature of the material and fourth one is temperature. Okay, what are the factors affecting resistivity? Only one factor, that is the temperature. Okay, now we want to check what's the unit of resistivity. For this we can use this equation, resistance R is equal to rho into L by A. On rearranging this equation, we can write rho equal to RA divided by L. We know that the unit of of resistance. Unit of resistance is ohm. Okay. Unit of area meter square. Divide by unit of length meter. Okay. We can cancel. Then what about the remaining terms? Ohm meter. Okay. Unit of resistivity is ohm meter. Now we want to discuss about what about the resistivity of metals, alloys and the insulators. Resistivity of the metal. It's of the order of 10 raised to minus 8 ohm meter. Resistivity of alloys. It is of the order of 10 raised to minus 6 ohm meter. And resistivity of insulators. It's of the order of 10 raised to 12 to 10 raised to 17. Okay. From this data, it is very clear that insulators are having very high resistivity. But on comparing metal and alloys, from this data, it is very clear that alloys are having higher resistivity than that of metal. Due to this higher resistivity, due to the high value of resistivity, it is used for making electrical devices such as electric iron, electric toaster, etc. Okay. Due to this high resistivity, it does not undergo any oxidation. Oxidation means it's a type of corrosion, that is destruction of metal. Destruction of metal will not happen in alloys. Okay. So alloys are used for making electrical devices. Okay. When we move on to metal like tungsten. Metal like tungsten, which is used for making filaments. Because of its high melting point. Okay. Metal like tungsten, which is used for making filaments because of its high melting point. Okay. Then metals like copper, aluminium, etc., which is used for making transmission wires. This is because of its high conductivity. Due to the high conductivity of copper and aluminium, it is used for making transmission wires. Okay, best conductor is silver. Then why silver is not used for that purpose? Because of its high cost. Okay. Now we can discuss some questions related to this portion. Our question is, will the current flow more easily through thick wire or thin wire of same material connected to same source? From this question, it is very clear that the thicker wire and the thin wire both are made up of same material. Thick wire and the thin wire both are made up of same material. That is, if this wire is made up of copper, this is also made up of copper. Therefore, the resistivity remains same. And again, it is clear that both of them are connected to the same source. Okay, both of them are connected to the same source. If V is the voltage applied there, here also V is the voltage which is applied. Then, according to the equation, resistance R is equal to rho into L divided by A. When the area of cross section increases, denominator increases, then resistance begins to decrease. Then according to Ohm's law, V is equal to I into R. When resistance decreases, V remains constant. To keep voltage remains constant because both of them are connected to the same source. Okay, to keep V remains constant, the term I begins to increase. What will happen here? Resistance R is equal to rho into L divided by A. Here the area of cross section is small. Area decreases. When the denominator decreases, resistance begins to increases. Then according to Ohm's law, to keep the voltage remains constant. When resistance increases, current begins to decrease. From these two, it is very clear that current flowing through the thicker wire is more than that of thin wire. Okay. Our second question is, let the resistance of the electrical components remains constant, and by changing the voltage to half of its initial value, then what happens to the current flows through the circuit? Okay. For this, consider an electrical component. Its resistance is equal to R. V be the voltage which is given to this electrical component. Now according to Ohm's law, V is equal to I into R. Okay. Now keeping the resistance remains constant. The voltage applied to this resistor reduces to half. Then what will happen to the current flows through it? From this equation, if R remains constant, V is directly proportional to I. Then when V changes to V by 2, current I changes to I by 2. That is, current reduced to half. I by 2 current which is flowing through this, and here the current flowing through it is I. Okay. I think this topic is clear for you. If you like this video, please subscribe and enable the bell button. Thank you.